There we go, yay. Yeah, if I tried to put that up on, if I tried to put Aerosmith up on, if I tried to put Aerosmith, can you hear me? Can you hear me?
Yeah.
If I tried to put Aerosmith up, I would get a copyright violation. I've done that before, where I played music in class and got copyright violations. So stand up, get those cameras on, get those cameras on. I need to see my students. Let me see your faces. Zach, Trey, Colin, Brad. I don't need Steven. Yeah, I need to see you guys. I need to see you guys. I don't need you zoning on me. I need to be there with you. Okay, stretch, stretch, stretch. Oh. Okay, let's sit back down. Let's sit back down. Where's everybody else? Where are you guys? You guys watching the videos. You guys watching the videos. I'm in your face. I need you in class. What happens on October 5th? What happens on October 5th?
We messed up.
Yes, you're going to be back with me. You're going to be back with me. If I can get a room big enough for all of us all the time, that's where we're going to be. I doubt I will, but I'm still hopeful. I'm still going to hope a little bit. Okay, I want to get you guys busy. Okay, we talked about the definition of the derivative last time. It was defined in terms of I'm not focused, Dr. Warren. It was defined in terms of the derivative is defined in terms of calculus is about
Limits, integrals, and derivatives.
Yeah, let me turn you down. I gotta turn you down since I turned you up for Aerosmith. Let me turn you down a little bit. There we go. That's right. Limits, derivatives, and integrals. We can see over here, by definition, f prime of 3 is defined in terms of a limit. It's defined in terms of a limit. It's the limit as x approaches 3. Now you guys write down at your seats. What's the fraction it's defined in terms of? You write down what's the fraction, because you're going to want to own this. You're going to want to own this when we have our next quest. Our next quest will not be next week. I'm hoping to get you back in the classroom to quest you. Write down what you have in your gray matter, not what you have in your notes, what you have in your gray matter for f of x. I'm giving you the answer, I'm an idiot. For f prime of 3.
The limit as x approaches what?
X approaches 3. 3, sorry, that's a 3. Okay, now I'm going to play singles. I'm going to pick on, I don't know, let me see here. I guess Kelly, sorry Kelly. Do you have anything for me, Kelly? Do you have anything that would be in the denominator? What do you have, Kelly?
In the denominator?
In the denominator.
I haven't started, but would it be x minus 3?
That would be exactly right, x minus 3. Okay, Kelly, you're off the hook. Thanks, let's give it up for Kelly. Come on, she's out there. Okay, let's right above Kelly is Griffin. Griffin, what do you have for my numerator?
F of x minus f of 3.
F of x minus f of 3. Awesome, let's give it up for Griffin. Who's the Gary Drivobus?
3.
Not the 3, but
X minus 3.
the x minus 3. Okay, here's your function. F of x equals x squared plus 2. It's a parabola. In fact, here's the graph of the parabola. If I get out of the way, here's the graph of the parabola. It's just x squared, then shoved up the y-axis too. There's your parabola. I want you guys, for this function, get your brains going. I want you to calculate f prime of 3 using the limit definition, not using what you learned in high school. Using the limit definition, just like we were doing in class last time. I want you guys to calculate, using the limit definition, f prime of 3. Find the numerical value that's associated with f prime of 3. So have at it. Okay, to breakout rooms you go. You guys should be in breakout rooms on the video also. So I'll help you out. I'll help you out. Since they're in breakout rooms, I'm going to talk to you guys specifically. So you're looking here, and you're trying to figure out what to do with this. Well, the first thing, and this would be on the second quest. You'd have to do the same thing. You put 3 in. You put 3 into your function. And when you do that, you're going to get 3 squared plus 2, which is 9 plus 2, which is 11. So that would go there. Then you put the x squared plus 2 into here. And so your next thing you would have is you would have x squared plus 2 into here, then minus 11. Okay, now I'm not going to write it down because we're going to come back and we're going to write it down. But if you have x squared plus 2 minus 11, that's the same thing as what? X squared plus 2 minus 11 is the same thing as x squared minus 9. Minus 9. And so you could have another line where you get x squared minus 9 over x minus 3, and you still have Gary Dreibelbis to deal with. You still have Gary Dreibelbis to deal with. But now factor and see what you get with that. So I'm just giving you some hints. I'm not going to do it. You're supposed to be doing it. Okay, what'd you guys get? What'd you get for f prime of 3? What'd you guys get for f prime of 3? What'd you guys have? What'd you have? Anybody get a number? Did anybody get a numerical value? 6. How many people got 6? Raise your hands. How many people got 6? Okay, so you've got Gary Dreibelbis to deal with. What's your first move? If you're going to explain to somebody else who doesn't know how to do this, what would you tell them your first move would be?
Find f of 3.
Find f of 3. So you plug 3 in, and what is f of 3? When you plug 3 in, what did you guys get?
11.
Yeah, you're going to be doing this on the second quest. So this limit is the same as Gary in the bottom, 11 here, and what goes in this location? What goes in this location?
F of x.
Your f of x, your x squared plus 2. Okay, is Gary been slashed yet? Has Gary been slashed? I probably shouldn't say stuff like this. Has Gary been slashed yet? No. So let's clean this up. And now suddenly, if I go 2 minus 11, I get a minus 9. Now, if you did this, if you just crossed the x and the x squared and the 3 and the 3 at that point in time, you should cause yourself physical pain. You should cause yourself physical pain. Okay, if you just slash the x with the x and the 3 with the 3, you're creating an algebraic hell for yourself. And you should get a stick and smack your hand like the old nuns would in the old days. 1800 nuns smack your hand. But I'm hoping nobody had to nun smack. I shouldn't say use the word nun smack. Okay, you have to use algebra to do this. What does this factor into?
X plus 3, x minus 3.
X plus 3, x minus 3 over Gary. Now finally you can pull out your slasher tool because this is multiplication. Now we're here. Now I need a 3 there. Is there any more division to worry about? Is there any more division by 0 to worry about? Is it a Frankenstein function? Is it a Frankenstein function? So then who can we call onto the field? Who's our star athlete? Who's the star?
Continuity.
Continuity, and we just plug the 3 in for x, and we get the number 6. How many people think if I gave you something like this on quest 2, you could probably do this? You could probably walk yourself through that. Because you're going to have to do something. You're going to have to do something like that. But I've assigned a lot of homework with that. Okay, now ask me, Dr. Warren, what does the 6 mean?
Dr. Warren, what does the 6 mean?
Good. That was Paris again. Okay, now everybody else put your hand on the space bar and ask the same question.
Dr. Warren, what does the 6 mean?
What does that 6 mean? Yeah, I mean, what could you give me something geometrically? Now the reality is that 6 changed the world. The reality is this 6 was part of a result that changed the world. But geometrically, it's not that interesting. It's still interesting, but it's not as interesting and as life-changing as you could think. Remember, Newton was number 2 in man of 1,000 years. Second in the most important man in 1,000 years, or woman in 1,000 years. Okay, number 2. So draw this graph. Okay, so I've got the parabola. You draw the parabola. Because this parabola, I graphed it so you didn't have to, is in fact a graph of this function. Now this 3 down here, I know you're still graphing. I'll let you graph. Then I'll start yelling. This 3 is the 3 we're interested in our derivative. This 3 is the same thing that we have here in our derivative. Now Paris was saying the first thing you want to do was plug the 3 into the function, and when you did that, you got the number 11 right there. And that's essentially saying, if I said, find f of 3, doing it the graphical way. How do we do it, guys? If I say, remember, you didn't know how to do this when you walked in the room, but if I say find f of 3, you go up, and then you go over. Okay. Now, I know that the idea of a tangent comes from geometry, and it's related to a circle. So draw a circle. Pick a point on the circle. And draw a center. Draw a center of the circle. Draw a center to your circle. Now, to the best of your ability, draw the tangent line. To the best of your ability, draw the tangent line to the circle at that point. So using the best of your ability, draw the tangent line to the circle at that point. And you guys should be doing this. You guys should be doing this in your notes also. Now what we notice is that the tangent line only intersects the circle in how many points? The tangent line only intersects the circle in how many points? 1 and only 1. 1 and only 1. And now let me tell you a story. I mean, I shouldn't waste time, but let me tell you a story. When I was a student at JMU, I was a graduate student, and so I took my daughter, because I had a daughter, my oldest daughter, who's 35. I took her over to Purcell Park. You guys haven't been to Purcell Park yet, have you? Has anybody been to Purcell Park? Okay, do you know the greenway that runs through campus? Do you know that greenway path that runs through campus?
Yeah.
Okay, do you know where the path that leads to Starbucks is? Has anybody been on that path before? The path that leads to Starbucks. If you follow that path past Starbucks, it'll take you to Purcell Park. If you like jogging, there's a really nice 1.5 mile loop over there that you can run that's a nice gravel loop. Or you can just walk a dog, do whatever you want. It's a pretty nice park over there. It's not far. It's only about 2 miles from campus, only about 2 miles from campus. But I had my daughter over there, and I don't know, you guys might be too young. You might be too young. But did they have these when you were kids? They now removed them from every park. Did they have something where it might look something like this, where they had bars, and then you would ride on it, and they would push you the merry. Would you guys remember that? Are you young enough to, old enough to remember that?
Yes.
Okay, they don't allow those anymore. But I took my daughter to the park over there, and they had one of these. They also had a slide that I know you guys were. They had a slide where you went up about 20 feet in the air, and then it spun around like this, and you'd come down to the ground. Those I think were pulled out before 2000, when you guys were born. When I was a kid, we had slides that were 16 feet tall, no spinning around. You went straight down. You would climb up 16 feet into the air and go straight down like that. And I mean, like, that was some serious fun. We had swings that were 16 feet long. And you would swing and swing and swing, and then you'd jump off at 16 feet into the air if you're dumb enough to do that. And maybe you broke a leg, but it was your own damn fault. It was your own fault. It was your parents' fault. It wasn't the city's fault. Okay, but enough of that, enough of this.
Dr. Warren, do you speak from experience when you say that?
Maybe a little bit. Okay, so let me go back to the park. I had my daughter on this thing. She was 5. It was the middle of the day. I was a student. So she's there, and she's sitting on the edge, holding on. And so I start pushing her. And then she's on board. First of all, I'm like, okay, I'm at the park. And I don't know, you can only listen to a 5-year-old for so long until your brain starts melting away, if you know what I mean. You're like, sorry, I know that, blah, 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 blah. And I'm just like, okay. And then she kept going, faster, Daddy. That's what she said, faster, Daddy. So I'm like, okay. And then she goes, faster, Daddy, faster, Daddy, faster, Daddy, faster. And then suddenly I started thinking about Tesla. Not the article, but the man. And he was saying if you keep adding energy to a system at a certain point in time, you can hit its natural frequency and you can break the system. And I kept thinking, if I keep pushing at a certain point in time, it'll keep gaining speed. And then I kept thinking, and then I forgot completely my daughter was on this thing, okay? Because I'm in my ADD state, and I do that. And the next thing I do is I look up, and my daughter her hands are this, her body's there, hanging like that, and she's spinning around like that. And I'm like in disbelief, and I'm just like, if I grab it and pull it, boom, I know she's gone. But then it didn't matter because her little hands couldn't hold on anymore, and she fell, okay? And all I could think, it had rained, all I could think was the physics work. All I could think, not about the safety. My daughter was going around like this, like that direction. She lets go here. All I could notice on the ground, was a mud slide along the tangent line. That's all I could imagine, that there was this mud slide along the tangent line. Her little body was over here, right on the tangent line, just like the physics would expect it to happen. Aren't you glad I'm not your father? Aren't you glad I'm not your father? I can't really get it across to you how important a tangent line is. We got to the moon by a tangent line. I know it doesn't seem possible, but do this. Imagine that you got a sling, like little David. You got a sling, you're swinging around, and you let go at a certain point in time. Which way is that rock going to fly? Along the tangent line. Okay. Now, while the tangent line goes back to the Greeks as far as a circle, we can extend it to functions. So to the best of your ability, draw the tangent line, what you think the tangent line would be on your graph that would go through the point 311. Do your best to draw the tangent line that would go along, that would be tangent to the point 311, and tangent, go through the point 311 and tangent to that function. Okay, now go to grid view. Now go to grid view. Go to grid view. And hold up what you've got. Go to grid view. Hold up what you've got. Go to grid view. Let me see your tangent lines. Let me see your tangent lines. Hold it up. I want to see your tangent line. What do you got for a tangent line? Hold it up. Hold it up. Okay, Zach, your tangent line's kind of running through your parabola, like you shot it and killed it. I want you to just grace it. I just want you to grace it. Trey, you're kind of going through your parabola too. There. Let me see here. Yeah, Griffin, you've shot your parabola also. Ah. Che, hold that up, Che. I'm probably saying your name wrong. Look at Che's. Look at Che's. Do you see how he's just wounded the parabola? He hasn't like shot it through. He's just kind of graced it there. Yeah, look at Mason's. Mason, you just took it away. I just said look at Mason's. Sorry, Mason, hold it a little. Yeah, look at Mason's. You can see Mason's there. You just kiss the parabola. Say that.
You just kiss the parabola.
Okay, yeah, so you want a line. Make me number one. Make me number one. Make me number one. You want a line that just kisses the parabola. Kind of like with the circle. It only intersects at that point. And only that point. A lot of you guys shot. You secanted your circle instead of tangented your circle. See, when I draw a line that just kisses that parabola. Now imagine you're on a roller coaster where we're flying above, where there's a roller coaster. Okay, it's attached magnetically to this track that's on this parabola. No. It's not like we're going down. It's not like we're going down and then up. It's like we're looking from above and we're on this path and we're swinging somebody around. We're swinging somebody around like this. And then what we're going to do is at this moment in the track, we're going to release the magnet. Now that would be a fun ride. I mean, like think about it. You're swinging around. And at that point in time, you're going to release the magnet. And then the cart is going to go along the tangent line that you just drew. Can you imagine people crapping their pants when that happened, when they realized the track's over here and their cart's going that way? They'd be like, oh! But then magically, you have something over here to catch them, okay? And send them merrily along their way. Now, that's a Disney ride I want to build. That's a Disney ride I want to build. Now, do you think, Disney builders, we should be able to find the equation of this line? If you're building that ride, would that equation of that line be important to the person riding the ride? Well, no. If you don't do it right, they die. If you don't do it right, they die. I want to find the equation of a line. Now that takes us back to quest 1. And here's 2 points. Look at these 2 points. I got the point 311, and I've got the point 418. Let's see what you remember. Find the equation of the line. Find the equation of the line that goes through the point 311 and the point 418. See, this is so good, I can see you guys. I can tell you need more time. I can tell some of you need more time. All right, for sake of time, you tell me what to do. I'm now in your hands. You tell me what to do. I want to find the equation of the line that goes to the point 311 and 418. Tell me what to do. What do I do?
Find the slope.
Find the slope. Okay, that's only Paris. Only Paris. So Avalon, how do you find the slope?
You do y1 minus y over x1 minus x.
Okay, I like where you're heading with that. Okay, but maybe we'll just do it in more of a classic way. You're right, Avalon, you can get it that way. But what's the classic slope formula, guys? What's the classic slope formula?
Rise over run.
Rise over run. How about in terms of the x1, y1, and x2, y2? What's the classic slope formula?
Y2 minus Y1.
y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1. Now, how do I use that with these guys? How do I use that with these guys? I would have, that would mean, if this is m, then that would mean 18
minus 3.
minus 11, y2 minus y1 over x2 minus x1. Okay, and so that would be 7 over 1, which is 7. What's your next move? What's the next move then, guys? What's the next move?
Find B.
We could find B. Y equals mx plus b. Well, do you know m now? Do you know m? Do you know m? M is 7. That's not a 6, that's a b. Now what do? How do you find b? How do you find b? How do you find b?
Plug in a set of coordinates.
Plug in a set of coordinates. You can choose this one or that one. You could choose this one or that. Let's just choose this one. I would have y 11 equals 7 times 3 plus b. Then you would have 11 equals 21 plus b, which would mean b is equal to what? Which would make b equal to what?
Negative 10.
Negative 10. So what's the equation of your line? What's the equation of your line?
Y equals 7x minus 10.
Y equals 7x minus 10. How much of high school was dealing with lines in that? I mean, go back, think about from 7th grade on, how many times did you deal with lines?
A lot.
A lot. Now I'm going to write down another formula for a line that's more important in this class than y equals mx plus b. Dr. Warren, I wasn't listening at all. I'm going to write down another formula for a line that's more important in this class. I'm bullying you. I'm bull. You're not focused, so I can do. Okay, now you're awake. Sorry, English can't come. Instead of y equals mx plus b, I want you to write this down. Y minus y1 equals m times parentheses x minus x1. Y minus y1 equals m times x minus x1.
Dr. Warren, can you say that again?
Yeah, I'll even write it while I write. Y minus y1 equals m times x minus x1. This is called the point slope. This is called the slope intercept. And you're like, Dr. Warren, explain. Okay, B is your y-intercept. M is your slope. I explained it. This is called the point slope. M is your
Low.
slope. X1, Y1 is your
Point.
I explained it. So let's just pick this point. If you could pick either one, it doesn't really matter. So I would have y minus 11 equals our slope, 7 times x minus 3. And this is just as valid as that. It's not hard to get from here to there using a little bit of algebra. It's not hard to get from there to there. But I think this is a better form than this. In this class, we're going to use this form of the line most of the time. In our class, we're going to use this form of the line. Now, what's this form called again?
Point slope.
Point slope. So let's test you. I've got a line. Now I'm not going to give you 2 points. I'm going to give you the slope. Oh. Cheap shot. Give me a slope. Throw me a slope.
7.
7. Maybe we have already used 7. I heard that 12. Give me a point. I'll keep going. I heard a 5. I didn't hear any other number. 9. Find the equation of the line. Find the equation of the line that has a slope of 12 and goes through the point. 5, 9. And you should have that karate already out. You should be able, woo! The equation would be, woo!
Y minus 9 equals 12 times x minus 5.
And there's the equation of the line. Done. You know, like Dr. Warren, what does this have to do with our roller coaster? Okay, to find the equation of a line, you either need two points, or you need a slope and a point. Either way, you can find the equation of a line. You give me 2 points, or you give me a slope and a point. Now here's the thing that made this so impossible. Here's our tangent line. It kisses the parabola. Say that.
It kisses the
It kisses the parabola. It only intersects the parabola at one point. So we can't use the 2-point formula. And you're like, well, Dr. Warren, then you've got to know the slope. But you're like, it's a parabola. How could we possibly find the slope of this line? Do you see the line? Can you visualize the line? Do you see the line? But yeah, guys, until Fermat in the 1500s, you would never have found the equation of the line. Because it's impossible. It's impossible. You can see the line, you can visualize the line, but the idea of, it goes through the point 311, you have a point. But it doesn't go through any other point. It doesn't go through any other point on the parabola. And then Fermat came along and said, well, let's cheat. Let's pick a point that's not quite 3. Let's just call it x. So mark it as x. then let's go up and hit the parabola. Let's go up and hit the parabola. We go straight up. There's my parabola. There's my parabola. Then I go over. So if this is x, then this would be, if this is x, then this would be y. But more important, this is 3. This is, if you say 11, I'm going to vomit. It is 11. This is f of
3.
3. Okay, let's do this. If this is ice cream cone, where's f of ice cream cone? If this is ice cream cone, where's f of ice cream cone? What do you do? If this is ice cream cone, how do you find f of? You go up and over. There's f of ice cream cone. If this is x, then this would be
F of X.
f of x. Stand up, stand up, stand up. I can tell you need it. Stand up, stand up, stand up. Stretch, stretch. Yawn, yawn. Get it out of your system. It's almost the weekend. It's almost the weekend. Yawn. I yawn too. Oh. I hope that goes away. Good. I'm back. I'm back. Okay, sit back down. Sit back down. Okay, get out of straight edge. Get out of straight edge. Okay, anything that's straight. Use a tissue box for all I care. You gotta have something in your room, a book, anything. Draw the line. Draw the line. Yeah, Henry, I like that tissue box. Draw the line that goes through this point and that point. Draw the line that goes through this point and that point with a straight edge. And I'm gonna do the same thing. I've got my straight edge here. I've got my straight edge. So I'm gonna go like this. And like that. Now, how many people recognize that's not the tangent line? How many people was that a different line than your tangent line? When you drew that, was that a different line than your tangent line? Okay, what are the coordinates of that point? What are the coordinates of that point? What are the coordinates of that point? I'll keep asking. You're over x, and you're up, you're up, you're up, you're up, you're up, you're up.
F of X.
F of x. Yes, Griffin, this is for you. I'm done. Go to grid view. 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 Now look into the camera. Look into the camera. Look at those eyes. Look at those eyes. Do those eyes look ready to learn? Look at those eyes. Do those eyes look excited to learn? Do those eyes look excited to learn? Trey's like, yes, Dr. Wenham. Look at Kelly's eyes. Oh, Kelly, forget it. You're not showing. Christian, where's your eyes? Christian, can you show me your eyes? Christian, is your camera broken? Christian, are you not even there? Or do you have your camera off and you're like out drinking beer on your porch right now? Christian, is that what's happening? You're pretending to be in class, but you're not really in class? You should message me right now, Christian. Sorry, just kidding. Okay, now make me number one. Make me number. Oh, Christian did. Okay, thank you, Christian. You did message me. Did you call me an asshole? What did you? No, just kidding. No, just kidding. Okay. All right. Now you're awake. Now you're awake. Back to where we were. How many people recognize this line, even though it's kind of close, is not the tangent line? How many people recognize that it's not the tangent line? This is what it gives us, though. Now I have 2 points. Now I have 2 points. Could I get the slope of that line? Could I get the slope of that line? You're like, well, I think so. y2 minus y2 minus y2 minus over, I don't know what this means. X2 minus x1. So let's do that. If I'm thinking about the slope of this line I used my straight edge to draw, it would be y2. Well, who's in the position of the y2? F of x minus y1, which is 11, all divided by x2, which is
Minus
3. Okay. Now you can begin to see. But if I come over to here, who was 11? If you come over to here, who was the same as 11? F of 3. And now you're like, huh, Dr. Warren, that's looking a lot like our definition of a derivative. In fact, it's the exact same numerator and the exact same denominator. Now the problem is, this line that we drew with our straight edge is not our tangent line. So this is not the slope of our tangent line. Say that.
This is not slope of our
tangent line.
But if I cheated x in, draw nothing. If I moved x in a little closer to 3, came up, hit the parabola, which would move f of x down, would the new line that I draw be closer to the tangent line than the one before?
Yes.
Yes. This would be closer to the slope of the tangent line. Now, if I took the limit as x got closer and closer to 3, I can't go all the way to 3 or I cause division by 0. If I took the limit, that would be the slope of the tangent line. Oh, Dr. Warren, we've done that already. It's the number 6. So the slope of my tangent line is 6. It's the derivative. So if somebody asks geometrically, what does the derivative represent? It's the slope of the tangent line. Now, you have a point and you have a slope. Can you find the equation of the line? You have a point and you have a slope. It would be y minus y1. Now, there's my y1, 11, equals the slope, which was the derivative, which is 6, times x minus 3. Tell your engineers to build along that line. That's where the cart will be caught. Tell your engineers to build along that line. There you can catch the cart. If you build it along there, you can catch it up here. Okay, let's write down a flashcard. And then we're going to end class. Let's write down a flashcard. So write down tangent line. Okay. Does anybody know about, is it Pavlov's dog? Do you know that? Is it Pavlov's dog? That he would ring a bell and feed the dog, and ring a bell and feed the dog, and then if he just rang the bell, the dog would salivate? Okay. When I say tangent line, bing. This is what I want you to write down every single time. I don't even want you to think. It should be almost like salivating, like you're gonna do when you go eat lunch here in a minute. I say, pick a tangent line. Any application, anytime you hear the word tangent line, you write this down. Y minus f of c equals f prime of c times x minus c. Anytime you hear the word tangent line in this class, you write down that formula automatically. It will save you every single time. Okay, now close your eyes, 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 close your eyes. Christian, I think your eyes are closed. Kelly, I think you're... Okay, tangent line. What do you say? No, Dr. Warren, I can't find my space bar. Tangent line, what do you say? What do you say? Y minus f of c
equals f prime of c times x minus c.
Okay, good, good. I think that's horrible. Okay, let's try it again. Tangent line.
Y minus f of c equals f prime of c.
Okay. We'll pick up with that. We'll pick up with that on Monday. Tangent line. Okay, see, you're already salivating. You're already salivating. Okay, we'll pick up with tangent line on Monday. We'll pick up with it. I want you guys working in the homework that I put up. I put up some new homework that has to do with tangent line. It has to do with tangent line. Okay, it's in what was due today?
The
WebAssign. I probably won't put up a new WebAssign this weekend. Okay, have a safe weekend. Have a safe weekend. Thanks for coming to class. Thanks for coming to class.
Thank you, Dr. Warren.
See you guys.
Thank you, Dr. Young.